All right, so I got 3.1. 3.1 is completely different than chapter 1 and chapter 2. Completely different. So if you, struggle a little bit, chapter 1, chapter 2, whatever, we're going to see a little tiny bit from chapter 2 today, just a little tiny bit. Everything else completely new. Okay, so brand new start for you. Pay attention, take notes. What we are talking about today, we're talking about what are called relations. Okay, a relation. And a relation is a group of ordered pairs. That's what it is. It's a group of ordered pairs. Now, ordered pairs, we know, for example, right? We could have the ordered pair 4, 3. That's an ordered pair, right? A point on a graph. That's what we're talking about. Ordered pairs, points on a graph. And we know that each one of these is x comma y. The x comes first, the y comes second. Side to side first, up and down second. Right? This is all stuff that you learn in terms of graphing points. So a relation is just a group of ordered pairs. So for example, let me write up a relation here. Okay, there's a relation. Group of ordered pairs. Okay, it doesn't have to be a pattern or anything. Just a group of ordered pairs together is a relation. Okay. What we're going to concentrate on today is a specific kind of relation. And a specific kind of relation that we're going to talk about is called a function. Okay, and you can see that with our I can statement. I can understand the concept of a function, which tells you what I'm about to put up here is a big deal. That's exactly what our I can statement is about. So a function is a relation in which every x value has exactly one y value. One y value, forgot the y. Y value. Let's write that down. Let's make sure we have it. That's an important sentence right there. And we'll talk about what it actually means after you guys copy it down. The function is a relation in which every x value has exactly one y value. So if you look at this relation, this is a function. Every x value that you see has a y value associated with it. Great. Let me show you an example of what's not a function. Okay. So this is not a function. So using our definition, a relation in which every x value has exactly one y value, and knowing that this is not a function, this does not follow that rule. I want you to talk to somebody, see if you can figure out why is this not a function. Talk to somebody.
Yeah, I really have no clue. Because it's not. Yeah, x value. Every x value. So there's no one x, so you can't repeat a function. Yeah.
Okay, so why do we think, and you might be wrong, you might not be right, whatever, brand new. Why do we think this isn't a function? Why do we think? Ian, what do you think?
Because 3 doesn't equal 4, 6 doesn't equal 2, 7 doesn't equal 0, etc.
That's not why. Nope. It magically became not a function when I added this last one in. It was a function before that. Now it's not. Josie?
Is it because you repeated the 2?
Because I repeated the 2 and look at the y's. The y's are different. So now I've got one x value that goes to 2 different y's. Our definition says every x value has one y value that it goes to. So you can't have the same x go to 2 different y's. Right? That's the big deal about functions right here. That's how we are going to determine if it's a function or not. You cannot have one x value go to 2 different y values. Y values can repeat all we want. We don't care about y values. Okay? But if x values repeat, They cannot go to separate numbers. Then it's not a function. Okay. So let's look at some examples. Now that we have a better understanding of what a function is, let's see if we actually do understand what a function is. So I got 4 examples here of relations. Some different ways. Talk to somebody, are these functions or not? Based on our definition.
It's not. C and B are not. Oh yeah, B also is it? Well, everything else is C and B are not. Yes, you're not functions.
Okay, here we go. Here we go. All right. Is a function? Yes or no?
Yes.
Yes. Hey, here's a trick. If all the x's are different, automatically a function, right? Because they don't repeat. So if the x's are all different, automatically a function. Okay, we don't even have to check anything else. B, yes or no?
No.
No, because the 4, we have a 4 that goes to 2 different y values. Great. C, yes or no?
No.
No. 0 goes to 2 different y values. Not a function. D, yes or no?
Yes.
Yes, those arrows represent ordered pairs here. So this is -1, 4, 3, 15, 11, 15. We said the y values can repeat as much as we want. We don't care about if the y values repeat. The x's cannot repeat and give us different numbers. Okay. Yeah.
So I'm guessing it doesn't count if it's negative, like it doesn't matter unless there's 2 negative same numbers.
Correct. Yeah, so like a 1 and a -1, completely fine. Right? There's not 2 negative. Yes.
Basically, the y doesn't really matter unless.
The only time the y matters is if we have repeat x's, we have to make sure the y's are different. Because if this was a 5, this is still a function now. Because that one x value gave me the same y value each time, and that's okay. So if the x's repeat, you got to make sure they give us different y's. Then it's not a function. Okay. Good. Questions on what a function is? Tell the person next to you, what is a function?
It is when it's a relation in which x value happens and you can't have the same x go to a different
Oh yes.
Okay, here we go. Here we go. Yeah, Taryn. Nope, not yet. Okay, so now the person next to you, I want you to look in terms of a graph, knowing the definition that we know. Talk about these 2 graphs. Are they functions or not?
A is not and B is.
I know A is in.
Make sure you tell them why or why not.
Yeah, and also it's not 5. Well, A is a scalar.
Oh,
Okay, here we go. I know we're still talking about it, but I want to move us along here. Okay? I told you there's a lot of stuff today. Is A a function or not? No. Raise your hand and tell me why not. Why not?
There's 2 different x's, but the y is different.
Perfect. Yeah, like right here, right? You got the same x value of 2, but different y's. Same thing over here. You got x's as 5s, but the y's are different. Not a function. Okay? Is B a function?
Yes.
B is a function. Why?
Because it's a diagonal line, so there's no way there can be 2 of the same x.
Yeah, exactly. The x's are always going to change, right? There's an infinite number of points on this line, right? All of those are points, and all the ones in between those are points. But all of those points have different x values. So if they have different x values, it's function. So what we are using, whether or not you realized it, we use what was called the vertical line test. Okay, the vertical line test says if I can draw a vertical line, vertical straight up and down. If I can draw a vertical line anywhere on my graph and it crosses twice, it is not a function. Because that's basically what we just said, right? Those vertical lines represent our x values. And so if there's a vertical line, one x value that has more than 1 point, it's not a function. Over here, I could draw any number of vertical lines, and it's never going to cross more than once. So if it doesn't cross more than once anywhere, it's a function. If it does cross more than once, not a function. Okay? That is the vertical line test, drawing vertical lines to tell whether it's a function or not. If it crosses twice, not a function. If it only crosses once, function. Okay. I want you to take 30 seconds and write something down about vertical line tests. Write something down about it. And once you have something down about the vertical line test, tell the person next to you which of these are functions and which are not.
So all I know is that oh, right. So I mean, the other way. See, look, it's an infinite circle, so it crosses it infinite times. Oh, yeah. No, that one is not. That was 3 of them. Yes.
Okay, here we go. We are talking vertical line test here, right? Vertical line test. Okay, talking about this one first. Austin, what do you got?
That one is a function.
It is a function. Vertical line only cross once. It is a function. Okay. Terrence, how about this one?
Function.
Yes, same thing. Only cross once. Okay. Tanner, how about this one? Not a function. Crosses twice. Right? What about this one? Weston? Why is it not a function? It's a vertical line, right? You draw on a vertical line, it's going to cross all the time. An infinite number of points it's crossing. This is not a function. Okay?
No.
All lines are functions except for this one. All lines are going to be functions because lines are straight by definition. Okay? All straight lines are functions except for vertical ones. That's the one they're going to try to trick you on. Okay? Quite honestly. When I say they, I mean the test. So really, so that's when I'm going to try to trick them. Okay?
Aww.
Don't get tricked. Vertical line, not a function. Awesome.
So a line is straight by definition, correct?
Correct.
What about that one where there's that a line?
This?
Yes.
No, it's a curve. I'm sure it's got a better name, but by definition, if we say line, it means straight. All right, moving on. Moving on.
A curving line is the same thing as
Hey, I told you we got a lot of stuff to talk about still. Okay, still going. The next thing we got is this idea of domain and range. Okay, domain and range. The domain is the set of all possible input values. The range is the set of all possible output values. We haven't talked about input and output. Input is just X. Output is Y. So our domain are all the possible X values. in a range are all the possible y values. We'll take a look at what that looks like. I'll give you 30 seconds to copy it down. We talk about domain and range, right? We talk about domain, all possible x values. That means in my relation, in my graph, however it's represented, what are the possible x values that I could have? That's what we're looking at, okay? The possible x values that we could have. So I'm going to take it back to our first relation that we saw, okay? The very first one that we saw when we were just determining whether it was a function or not, okay? If I want to say the domain and range, domain again, domain is all x values, all the x values. All we're doing is we're listing the x values. That's it. It's a list of numbers. So our domain, the possible x values that I have, I've got -2, -1, 0, 1, and 2. That's my domain. Those are the x values in my relation. Okay, my range are the y values in my relation. What y values do I have? There's
2 and 0.
2 and 0. And I don't need to repeat them. I can just write them once. Because we're not saying how many of each one there are. We're just saying what are the possibilities. The only possibilities we have for y are 0 and 2. That's it. So don't repeat them. Just write them once, whatever your y value.
What about the numbers in between?
We don't worry about the numbers in between because those aren't possible. These are the only dots on our graph. These are the only points that we have. So the only y values we could possibly have when we look at this, it's either a 2 or it's a 0. That's it. Okay. So if they just give us points, it's just listing numbers. Okay. Just if it gives us points, it's just numbers. So when we see a graph, like the one on the left, and it's dots, it's just points, that's just going to be a list of numbers. It's going to be a list of possible x values and possible y values. So our domain are x values. Domain, our x values are side to side. That's our x, right? Side to side. So what possible x values do I have here? Where are my x values located on this graph?
Sideways.
Well, we're going this way, right? Okay, Emma, what do we got?
-3, -2, 1.
And -3. This is at -1. Careful. 1 and 3. Okay, so I'm looking at what x values do I have? Those are the x values I have. -3, -1, 1, and 3. Those are the x values that I have for those points. Okay, our y values, we look up and down. What are the y values that I have here? Braden?
4, 2, 0, and -2.
There you go. Okay, those are the y values that I have. Up and down. I got -2, I got 0, I got 2, I got 4. That's where those are located on the graph. Okay, domain and range. Awesome.
I noticed these two things are a pattern. They're always +2.
In this case, yep, because it would form a straight line, it's going to be a pattern. It won't always be that way. But on this one, yeah. It doesn't necessarily. Most of the time, the book's going to put them in numerical order, smallest to greatest. Yeah. So if you want to do that, otherwise, awesome.
Why is it 3x?
No, it does not.
It says the function.
That's a different problem. That's not this one. That's not referring to this graph.
Okay. We need to know that.
No. If we would needed to know that, I would have shown.
Okay.
Okay. All right. And then we get into here. Okay. Now, remember, there's an infinite number of points here, right? So I can't just list out numbers anymore because you're going to be writing literally forever because there's an infinite number of points in there, right? There's the 0.1, 1.1, 1.11, 1.105, right? There's all those numbers. So we need a way to represent that x could be anything from here all the way up to here. It could be anything between here and here. Any ideas on how we can represent that x could be anything between those two? Maddie?
-2 through 3.
Okay, how am I going to say that though without writing the word through?
Okay, 1, 2, 3.
Nope. Ian, what do you think?
An inequality.
Inequality. This is the one little part of chapter 2 that comes back. Okay, is x could be anything between -2 and 3. Okay, we have to have a compound inequality here for our domain. Anytime this is what we call continuous, it's connected. If it's connected, we need a compound inequality. We need an inequality. Okay, right?
Is it always going to look like that? Like
It's always going to be the less than. It's going to have a smaller number here, bigger number here.
Okay.
Yep. Ian?
That's where I was coming in earlier when I said you have to put the numbers in between.
Yeah, so only when it's connected.
Yeah.
Right? Yeah.
Yeah, I have to graph them on those graphs.
Like graph ourselves.
Graph it yourselves? Not yet. No.
Not yet.
We won't have to graph anything like this. We're going to graph straight lines in this chapter, but not like that. Okay. And so our range. Okay, what's the lowest our y value could go?
-1.
-1. What's the highest my y value could go?
2.
2. There you go. Okay. So your domain is your side to side. That's your x. Your side to side, how far does it go? Your range is your up and down. It's your y. How far up? How far down does it go? Okay. Okay. The very last thing, and I know I told you a lot of stuff today. The very last thing is the idea of independent versus dependent variables, which should sound familiar
Science.
because of science, right?
So I can't go to
So independent variables, okay? Independent variables are the ones that we change, right? Independent variables are the ones that we can change. Dependent variables are the ones that change because of something. So if we had a word problem and we were talking about how much money we were going to spend on something, right? Let's say there's $25 a ticket. And we create this equation. You guys know how to create equations like this, right?
No.
What does X stand for in that situation? Number of tickets, right? That's my independent variable. That's what I'm changing. I'm changing the number of tickets. My dependent is the cost, the total cost. So in general here, what you need to know is whatever your X value would be, that is independent, and your Y value is dependent. Okay, they're going to ask you some questions today just to identify your independent and your dependent. Okay, summer work problem. You guys know how to do that. Whatever your X value would be, that's your independent. Whatever your Y value would be, that is your dependent. Yeah. There's really not a lot of work to show for any of this. You just got to put your answers down. Okay. Yep. You just got to put your answers down. Okay, that's it. Go ahead.